Hi YouTube, Tim Unkert here. In this video, we're going to approximate irrational numbers, specifically square roots, using the Babylonian method. And that method is you basically come up with an initial approximation. I'm going to show you how to make that. And then you add it to the number under the square root, divided by the approximation. You divide all of that by 2. So how do you come up with this initial approximation? Well, let's look at the square root of 47. So first off, we take the square root of 36. Well, that gives me 6. And what I'm doing here is I'm picking 36 because 36 is a perfect square and has a integer square root. And then I'll take square root of 49. 49 is also a perfect square. And the square root of 49 is 7. So I know that my value is going to be somewhere in between 6 and 7, probably closer to 7. So my initial approximation would be something like 6.8. So if I do 6.8 plus 47 divided by 6.8, and then I divide that by 2, well, what do I get? Let's take open a tab here and go to Desmos. So I'll do 6.8 plus 47 divided by 6.8, and we'll divide that by 2. And I get 6.855882. So 6.855882. Now, what is the actual value here? So let's do that in Desmos. So I'm going to do 47 and do the square root of that, and I get 6.855654. Okay, so the actual value is 6.855. Notice we're accurate to the thousandths place here, and then 654. Okay, so, and we can refine it further. Now, let me show you with this technique. Let's say I guessed a 6.7. Let's do 6.7 here. Okay, I'm getting 6.857, so I'm to the hundredths place. If I did 6.9, I'm still to the thousandths place. So I can get very close to the exact amount using this method. Now, if I'm doing this as a student on a test, the work that I might show would be, something like this. This is my work, and this is my estimate here, or my approximation, and I use this to get my initial value of 6.8 here, right? And if you're a teacher, I would encourage you to say that, yeah, that's pretty good. That's a pretty good way to approximate that irrational number. You can, of course, refine it. If you notice, if you do 6.8 times 6.8, you get like 46.24. Maybe you do 6.85 over 47 divided by 6.85, and you get a little bit closer and closer. And you get very accurate using this method, actually, which is quite cool. All right, let's look at a couple more, and maybe you want to take a moment, pause the video yourself, try these out, and see if you come up with a similar solution as to what I came up with. And also hit that like button if you're enjoying what you're seeing. Okay, so we're going to approximate the square root of 5 in this one. So what's a perfect square that's close to that? Well, 4. All right, if I take the square root of 4, I get 2. And what's the next closest perfect square is 9. If I take the square root of that, I get 3. So I might try something closer to 2 here. I might do like 2.2 because there's 5 numbers between 4 and 9. So break it up. So what I could do for my approximation here is I do 2.2 plus 5 divided by 2.2 all over 2, and let's see what I get with that. Let's go here to Desmos. Let's clear these out. So I'm going to do 2.2 plus 5 divided by 2.2 and divide all of that by 2, and I get 2.236 with the 3/6 repeating. Okay. Okay, so what is the actual value here? Let's go to Desmos and see. So if we do raise 5 to the 0.5 power, that's taking the square root. So we get 2.36067. Okay. So again, with this method, we're accurate to the thousandths place, which is pretty accurate. 067. Okay. So again, I would show my work like this if I were doing this on a test as a student, or if I was checking this as a teacher, this is what I'd want to see. Okay, let's look at problem 3. Go down page here. All right, so problem 3, we're approximating the square root of 11. So 9 is a perfect square that's close to that. Square root of 9 is 3. The next closest is 16. Square root of that is 4. So this is, what, 7 in between 3 and 4. 7 from 9 to 16. We're at 11, so 2/7 of the way. Well, let's just divide 2 by 7. So it goes in, let's see, twice, 14. So maybe 0.28. So let's do 3.28. Let's refine it. See if this works. 3.28 plus 11 divided by 3.28 all over 2. What does that equal? So we'll do 3.28 plus 11 divided by 3.28. Divide that by 2, and we get 3.316829. Is it 3.316? 316,829. Okay. Okay, what's the actual value of the square root of 11? So we do 11 raised to 0.5 power. We get 3.316624. So again, we're accurate to the thousandths place using this technique, which is pretty cool. All right, let's do one more. So square root of 17. So what's close to 17 here? Well, 16 is a perfect square that's close. Square root of 16 is 4. And then we have square root of 25. Is the next closest. Square root of that is 5. So it's somewhere between 4 and 5. There's a gap of 9 here. We go 1/9 away. So let's do 1 divided by 9. 9 goes into 1, well, 0.1 times. So we get 9. So we just get like 0.1 repeating. Let's do 4.11 plus 17 over 4.11. And we'll divide that by 2. So we're going to do 4.11 plus 17 divided by 4.11. And we'll divide it by 2. And we get 4.123126. Cool. All right, let's see what it actually is. So we'll do square root of 17. And we get 4.4123,105. So again, we're accurate to the thousandths place using this technique. Pretty sweet. Hopefully you enjoyed this video and it was helpful to you. If it was, please like and subscribe. Also, teachers, if you're watching this, I have my link to my teacher pay teacher store in the description if you want to support the channel in that way. And also, I'll leave a link to my website as well. Hope to see you in the next video. Have a great day. Bye.